Hello everyone, it's Daniel from TechMind Factory, and this is the next video from the series about cloud pharmacy, my new open source project which is available on GitHub. The link is provided in this video description. In this video, I would like to talk about patient verification using Azure AD verifiable credentials. Before we jump into the cloud pharmacy source code and Azure resources, I would like to talk a little bit about verifiable credentials and implementation provided by Azure AD team. So let's start. Let's start with the solution architecture diagram. In this video, we are going to talk about these three elements from this diagram: Azure AD Verifiable Credentials Service, and Microsoft Authenticator mobile app. So this is our focus in this video. And before we start, let's talk about some theory and let's talk about some concepts and scenarios before we move forward with implementation details. What you currently see on the screen is typical scenario nowadays. So there is this concept of identity provider. To make it simple, probably you know it, but let me clarify on this. Identity provider is the centralized identity management system where users can create accounts, identity of the user is stored, tokens can be issued. So in this case, identity provider can be Azure Active Directory, Azure Active Directory B2C, it can be Auth0, Okta, anything else. So in this case, when it comes to managing user identity, it's centralized. So I have this one identity provider. Let's say that I have my own company. I'm using Azure AD in this company. So this is the centralized place where I have identity of all my employees. So every time those employees want to access company's resources, applications, they have to sign in with their corporate account. So in this case, Azure AD account. And the token is issued, of course, and then they can successfully use this token in those apps, and everything is fine. We have also this concept of federation, so trust relationship between identity providers. So the perfect example here can be the situation where I have web application which is secured by Azure AD B2C. I can use my standard account here, like username and password, but also there is this button underneath called Login with Facebook, and I can click it. I will be redirected to Facebook. I can use my Facebook account to sign in, and then I will be redirected back to my application, and my application knows my identity. Why? Because my identity provider, let's say Azure AD B2C, trusts Facebook. So there is a clear information, okay, it's Daniel. And this is perfectly fine, but there is a bunch of scenarios where this centralized approach with identity provider cannot scale and is limited, to be honest. So let me put an example here. Let's say that I live in one of the countries and there are multiple services and organizations in this country. So today, of course, we use this concept of ID card. Yeah, I have my ID, I can go to the institution, I can present my ID and I can say, okay, it's me, Daniel, could you please, for instance, generate this specific document for me? And this is fine, but it's limited because I have to present my ID, there is complicated verification process, and in general, this doesn't scale. On the other side, when you think about the concept where verifiable credentials can be used, I can have my verifiable credential in a digital way. I can have my ID card, let's say, with the data about me, and I can present this card to different organizations around the world. So let's say that I live in Poland, I have my ID card, my verifiable credential was issued, and now I can present this verifiable credential to other organizations around the world. And what are the benefits here when it comes to this approach? First of all, I don't have to physically present my ID card each time I want to go through the process of verification or just to complete some task. In this case, I can present my verifiable credential and say that, guys, my identity was verified in the past by this specific organization in this specific country. So you can be sure that you can trust me because my identity was verified in the past. And of course, you can say that, okay, Daniel, but we could build this trust relationship and use federation between those different identity providers. And okay, that's fine. But in this case, we have to really tightly couple those identity providers in this case. So every time I want to build this trust relationship, there is additional work required and I have to build this federation, yeah? And I have to connect those identity providers, which is not the case. I want to have decentralized identity here. So I want to obtain my verifiable credential, which proves that I'm Daniel and I am patient, like it's in the cloud pharmacy concept. And if I will go to any pharmacy store around the world, I can present that, please look, this is my verifiable credential. It was verified by this specific cloud pharmacy institution, so I'm eligible to obtain discount for medicaments, let's say. And of course, there can be some other key scenarios, like onboarding employees, partners, and customers in this case. So let's say that I have company and I work with third-party agency, which is responsible for external workers and employment in this case. So before those workers can access company resources, places, wherever, they have to be verified. So what can happen here? This third-party agency can, of course, verify the identity of those external workers. They have to physically present their ID card or upload the photo, wherever, but they have to identify themselves somehow. And once they do it, verifiable credential can be issued for them. And then if they want to, let's say, access company resources in my organization, they have to just present this verifiable credential and say, guys, look, I was verified by this third-party agency you work with. And right now, I don't have to present my ID anymore, submit anything. This is my verifiable credential and I can enter. And I can use company resources. Yeah, so in this case, it's really fast and efficient. Another example, access to high-value apps and resources. So we can quickly verify credentials from a wide variety of trusted partners based on the open standards. So this is exactly what I mentioned. Each organization can have own identity provider, which is fine, but I don't want to create user account in each identity provider, yeah? But on the other side, I want to verify this specific user, this specific person identity. So how can I do it? With verifiable credential. This person can present that this credential was obtained by this trusted organization. So for sure, this identity was verified before, so we can proceed. We don't have to verify this person once again. The access is granted. Another example, self-service account recovery. So in this case, with verifiable credentials, we can reduce support phone calls and security questions with simple approach, with verifiable credentials. Example, let's say that in a typical scenario, if our account is blocked or we cannot access it, we have to call the support team. We have to call our help desk. And we have to identify ourselves. Maybe we have to answer some questions, whatever, yeah? But it can be simplified. There can be a screen where we are asked to scan the QR code and present our verifiable credential. And in this case, I can prove that, please look, it's me, Daniel. I'm employed in this company. I cannot access my account. And here is the proof that I'm the person who I tend to be, yeah? And I want to verify it. So in this case, I can present verifiable credential, it's accepted, it's verified, and then I can recover my account without calling other people, without answering questions, without submitting any documents, whatever. It's simple as that. So let's dive into verifiable credentials a little bit more, and let's talk about Cloud Pharmacy example. And a small disclaimer here. When it comes to the Cloud Pharmacy and how I use the verifiable credentials, it's just a simple concept. So in the Cloud Pharmacy, patient can sign in, can generate, obtain verifiable credential, which is stored in the Authenticator mobile app on the phone. And this patient can present this verifiable credential in another web application, Cloud Pharmacy Store. And once the verifiable credential is presented, it's verified, the patient can obtain discount. And it's simple as that. Of course, you can say that, okay, but you know, this person uses the same account to sign in to both applications, which is obviously fine, yeah? And I'm verified because I got the token, I authenticated, but it's more about to see how to connect the dots, how to use the service, and how to issue and verify verifiable credentials. So in the Cloud Pharmacy, as I mentioned, there is patient portal. People can sign in, they can issue, they can obtain the verifiable credential, which is saved into the wallet. So in this case, when we talk verifiable credentials wallet, we talk about the Microsoft Authenticator mobile app. And once I have this patient card, this verifiable credential in my wallet, I can sign in to Cloud Pharmacy Store. I can open one of the medicaments details page, and I can obtain discount once my verifiable credential is presented. So this is like a simple concept, but underneath, of course, there is like, I would say, more interesting things are presented underneath. So when it comes to the Microsoft implementation and verifiable credentials, underneath we have public key infrastructure, so distributed ledger. It's called ION, Identity Overall Network. So ION is an open, public, permissionless layer 2 decentralized identifier network that runs atop the Bitcoin blockchain. So I encourage you to check the links I provided under this video, in the video description, to be more precise, because there is a lot of content to read and to understand, and there is not enough time to do it in this one single video. So I want just you to understand that once this verifiable credential is issued for the patient, underneath the decentralized identifier is used, and it's saved in the distributed ledger. So in this case, when I want to verify this patient verifiable credential in the Cloud Pharmacy Store, Cloud Pharmacy Store will make a lookup at the public key material in the distributed ledger, ION, and Cloud Pharmacy Store can be sure that, okay, this person, Daniel, is patient, and this verifiable credential was issued by Cloud Pharmacy, so this patient is eligible to obtain discount. So in the future, for instance, I could even decide to disable authentication in the Cloud Pharmacy Store web application. So I would open it for the anonymous access, but still during the process of buying medicaments, I can present this option to get discount after verifiable credential is presented. And nowadays, this anonymous shopping is very popular, so you don't have to create an account, you don't have to sign in to buy something in the store, yeah? But you want to still obtain the discount, let's say. So in this case, you could open Cloud Pharmacy Store application. You don't have to authenticate, but still you want to obtain discount. So you can present your patient verifiable credential, and then you are eligible to obtain this discount. So I really encourage you to check the links I provided in the video description, but this is about this decentralized identity here. Like I don't use identity provider to manage user identity centrally. So I don't want to keep it only for myself. There is this distributed ledger underneath, which can be used by many different organizations, yeah, to make sure that specific verifiable credential was really issued by specific organization. And we don't have to federate identity providers. We don't have to add additional configuration. In this case, we can just verify this verifiable credential using this distributed ledger underneath. And of course, Microsoft provides its own implementation of verifiable credentials using Azure AD service. So we have this user interface where we can manage our verifiable credentials. We have developer tools, SDK, API, and we have this end-user wallet I mentioned, so Microsoft Authenticator mobile app. But I want you to understand that this implementation is based on the standards. So it's not like Microsoft built something totally custom. It's not like this. Microsoft Azure AD verifiable credentials, it is based on the open standards. So there is this decentralized identity foundation, which is responsible for defining those standards, protocols, and flows. And Microsoft Azure AD verifiable credentials was built using those open standards in this case. So I want you to understand that it's exactly like with the identity providers like Azure AD, Auth0, Okta, and other identity providers. They provide different experience, user interfaces, integration tools, but underneath they use the same set of protocols and standards like OAuth 2 and OpenID Connect. So it's exactly the same with verifiable credentials. There can be other company which builds own solution based on the verifiable credentials, but underneath we have this set of standards to be used. And of course, it's not so. It's quite young when it comes to the concept. When it comes to OAuth, OpenID Connect, it's quite long on the market, I would say. So it's more clear. So we will see in the future. Okay, so now Azure AD verifiable credentials in the cloud pharmacy. So let's talk about what's happening inside our project in this video. Those are the print screenshots from my mobile application, from the Authenticator app I installed on my iOS device. And as you can see here is my patient verifiable credential I obtained in the patient web app. So here we can scan the QR code, we can add the credential to our wallet, and it will stay in this wallet in the Authenticator mobile app. So even if I decide to delete my account in the Azure AD, Azure AD B2C, or any other identity provider, my verifiable credential will stay with me in this Authenticator app. Of course, I can set expiration date here. That's possible, of course, but in general, I own my verifiable credential. So in this case, even if my account will be deleted in any identity providers, still I have my verifiable credential here in my wallet on my phone in the Authenticator app. And what is also important to mention is the fact that you don't have to use Azure AD or Azure AD B2C identity providers to integrate verifiable credentials, to use them. You can use any identity provider. So again, it's based on the standards and protocols. So you can use Auth0 for user authentication and to secure your applications. And you can still use Azure AD verifiable credentials to obtain verifiable credentials and store them in the Microsoft Authenticator mobile app. So that's important. And this is the presentation of the verifiable credential for the patient in the cloud pharmacy solution I built. So right now, let's see it in action. So let's talk about implementation details. Before we move forward, just a short reminder, in this video description, you will find a lot of helpful links. One of them, for instance, is the blog post about how to set up decentralized identities on Azure. So you will find detailed explanation how to configure this service. So I really encourage you to check the links because it will be really helpful to start with. Okay, great. So now let's talk about verifiable credentials in the Azure portal. So once you create verifiable credentials service in the Azure portal, you can access this service on the homepage. So here we click verifiable credentials. And of course there is this getting started page, but for us it's really important to see what is in the organization settings. So as you can see, here is my organization name, which I'm using. So it's TechMind Factory. And I know that it probably could be Cloud Pharmacy, but I really want to stay with TechMind Factory brand. So that's why I use TechMind Factory. And also I wanted to, in the future, integrate verifiable credentials with my domain, which is techmindfactory.com. Of course, there are some other parameters which will be required to integrate with verifiable credentials from the source code, like tenant identifier, decentralized identifier, and other parameters like key vault and other stuff. For us, it's very important to understand the part related to decentralized identifier. So let me show you this. If I will copy this identifier and I will open the Ion management blade, the link is provided in the video description. At the top I have Network Explorer. So here, if I will paste my decentralized identifier, after a few seconds, you can see here that my decentralized identifier is published. There is one key used, 2 endpoints, and 1 link domains, which is techmindfactory.com. So this is the place where we can verify, in this case, a Cloud Pharmacy organization. So my decentralized identifier is here. And we can go through different details here, like verification method, service, and so on. So I will not discuss the structure of this whole document you currently see on the screen, but I encourage you to go through the links I provided in the video description to learn more about this structure. So I just wanted to show you that because using the Ion Network Explorer, we can easily verify those decentralized identifier. So if we get back to the Azure portal and we move to the Credentials tab, you can see that I have 2 credentials. So the one I'm using here is Cloud Pharmacy Patient. So if I will open it, here is the credential URL here. So it's publicly available. We can open it. And this is, it's like a manifest to see information about this specific verifiable credential. And I will talk about it more a little bit later in this video. But if we get back here, it's also important to mention that here is the decentralized identifier used on Ion, my tenant ID, and of course the key vault that I connected for my verifiable credentials service. So this is the place where all the configuration parameters are stored for this specific Cloud Pharmacy Patient verifiable credential. So now let me open 2 files which are required to configure verifiable credential, which is rule file and display file. So let me open Visual Studio Code. To use verifiable credentials, we have to upload 2 files. The display JSON file and the rules JSON file. The display JSON file it's responsible for the presentation of the verifiable credential in the Authenticator mobile app. So on the right side, you can see how my verifiable credential looks in the Authenticator app. And on the left side, you can see the definition for this, I would say, verifiable credential layout. So as you can see here, There are a few details. So you can see that there is this card title, a patient, and we can see it on the right side. There is also this parameter called issued by, so Cloud Pharmacy. We can also see it on the right side. We can set the background color, so it's white, the text color, so it's blue, and there is also the logo URI. So this logo is uploaded on my public blob storage in the Azure cloud, so it's publicly available. And also we have this description, so Cloud Pharmacy patient. Yeah. And as you can see below, there is also this information that you can use your verified credential to prove that you are eligible to buy medicaments. Yeah? So it could be more precise, and I could say you are eligible to get discount for medicaments, but in general, it's something that will be displayed in the Authenticator mobile app, which is visible currently on the right side. Okay, and below, we have also claims. So claims are the values which will be stored in the verifiable credentials. So those claims, you can think about claims exactly like about claims in the ID token and access token. So claim can be the name, can be email, can be some custom attribute of the user. So in this case, you can see that I'm using two claims. So patient ID, which is visible on the right side, the patient ID, and also I have the patient name. So in this case, it's Daniel K on the right side in the Authenticator app. And before we move forward, it's very important to mention that those claims have to be somehow injected in this verifiable credential. So, as you remember, I mentioned that you can integrate Azure AD verifiable credentials with any identity provider, like Auth0 or Okta. So in this case, you can decide how you want to inject those credentials. Because sometimes there can be a scenario where you want to collect those claims from the user directly in the Authenticator app. You want to get them from the ID token that was issued by identity provider. But also you want to inject those claims in a custom way, like using the REST API. So in this case, you want to provide some details about the patient, but not from the ID token directly, but from other places. And you can say that, okay, I want to use those parameters in this verifiable credential. And this is exactly the approach I used here. So if we open the rules files, this is the file which is responsible for managing claims inside the verifiable credentials. So how this claim mapping will be proceed during the issuance, and how we want to obtain those different claims, and what is the validity interval in this case, and what is the type of this specific verifiable credential. So you can see that the type is Cloud Pharmacy Patient, so the name I use in the Azure portal. And also we have this section called ID tokens. Here we have the ID self-issued me. So it means that I want to manually inject those claims using, for instance, my REST API. So in this case, you can see that inside the mapping, I have patient ID, I have patient name, and here are those claims. So patient ID and patient name. And of course, we will see how those claims are injected here, but I want you to understand that there is this relationship between display file and claims you declared there, and the rule files and the claims mapping you configured. So if you wrongly configure those mappings, there can be an issue with verifiable credential and issuance process. That's very important. Okay, perfect. So now it's time to jump to the patient web app and see how to issue verifiable credential and talk a little bit about this process. Okay, great. Here it is, patient web app. And under my profile section, you can see that there is my first name, last name, national healthcare ID, but also there is this section called Get Your Verifiable Credential. And here is the information that we should scan the code with Microsoft Authenticator app. So I have to click generate the code. And of course, underneath this web application calls my API in Azure, which we are going to discuss in a minute. But I have this QR code with the PIN. So right now, I can open Authenticator app. I can scan this code, and the verifiable credential will be displayed in the Authenticator mobile app. And I can accept it, and I can add it to my wallet, or I can reject it, so I don't have to accept it. So if I will accept this verifiable credential and I will add it to my wallet, so to my Authenticator app, you can see that right now the confirmation was displayed and I have my verifiable credential in my wallet. So right now, if I will open Cloud Pharmacy Store web application and I want to obtain discount, I have to present my verifiable credential. But before we do it, let's jump into the source code to understand what happened underneath in this issuance process. If you open the source code I provided on GitHub, you will see that there is Cloud Pharmacy Patient API. So every time the user clicks generate code, the Cloud Pharmacy Patient app calls the Patient API, and inside this Patient API, I implemented this verifiable credentials service. And here is the method called issue patient verifiable credential. So if I open this implementation, of course, this is interface, but here I have this verifiable credentials service implemented. And if we scroll down, you will notice that here I use HTTP client. So in this case, I'm not directly calling verifiable credentials in the Azure cloud. I call verifiable credentials API that I created, and this API is responsible for communication with Azure AD verifiable credentials. And of course, you could implement this logic around verifiable credentials communication inside each API, like Patient API or Cloud Pharmacy Store API. But I decided that I want to have this implementation around communication with verifiable credentials. I want to have it in one API project for the future, because probably in the future I will implement more projects. So that's why verifiable credentials API project contains everything what is related to verification and presentation of verifiable credentials. Yeah, but if we get back to the patient controller, and here we open this issue patient credential command, we can see that I'm calling issue patient credentials async. And right now, what's happening underneath here, before I call this verifiable credentials API, let me show you really quickly. Here is the data I want to pass to verifiable credentials API, to the API I wrote for this solution. And here, for the patient ID, I want to use the user ID obtained from the ID token that was issued by the Azure AD B2C. And the first name and last name will be also taken from the token, from the ID token issued by the Azure AD B2C. And this is really important to indicate that, as you can see, of course, I obtained this data from the ID token and I want to send it to generate verifiable credential. But of course, I can get the identifier or first name and last name and any other attribute from other places. It doesn't have to be ID token from identity provider. Yeah? So this is the case that we don't have to tightly couple identity provider and Azure AD verifiable credentials and verifiable credentials at all. Like, I mean, we don't have to connect, we don't have to use Azure AD B2C to generate Azure AD verifiable credentials. It's not like this. We can generate these verifiable credentials using any other attributes here. But I'm using patient ID from the token, and I'm using first name and last name from the token for this specific patient who authenticated with Azure AD B2C account. And now, of course, here I'm adding the authorization header in this case, so the access token. So my Verifiable Credentials API is secured with the token, which is obtained using client credentials flow. So in this case, first I have to obtain the token from the Azure AD B2C, and then I can securely call Verifiable Credentials API. This is not the topic of today's video, but I just want you to know that this communication is secure, and in the future I have planned to explain in details how this communication is implemented here. But the most important thing here is the fact that we have to provide patient ID, first name and last name, and we have to send it to Verifiable Credentials API. So now, as you can see, we can use post as JSON async, and here we send the data to Verifiable Credentials API. So if I open this project, we have two controllers, issuance controller and verification controller. The issuance controller is responsible for issuing and generating verifiable credentials, so patients can get them and store them in their authenticator apps. And verification controller is responsible for generating the verification payload. So in this case, patient has to scan the QR code, present verifiable credential, and the patient can obtain specific discount. So let's talk about the verification process, as we mentioned before. So here is the controller, and of course there is some additional validation done. But what is important here, you will notice that there are two methods here. So the issuance request endpoint, and this endpoint is connected with generate issuance request async method. And this is the method responsible for generating verifiable credential request. So the patient wants to generate verifiable credential and store it in the wallet, so authenticator app. But there is also this issuance callback endpoint, and this endpoint is used by Azure AD Verifiable Credential Service to inform our API about the fact that something has changed. So for instance, that the user scanned the QR code. And once the user scanned the QR code, we can get a specific information from Azure AD Verifiable Credentials. And also, we have this confirmation after the verifiable credentials was successfully issued. So as you remember, in the web application, once I scanned the QR code and I generated my verifiable credential and it was issued successfully, there was this green label displayed that a patient verifiable credential successfully issued. And I managed to display this label because I obtained this information from the Azure AD Verifiable Credential Service. So I was informed about the fact that user successfully completed the process of issuance. So this issuance callback is very important here. And of course, probably you notice on the architecture diagram that I use Azure Function together with signaler service to send this real-time messages to the web application. This is not the topic of today's video, but I want you to know that once I got this confirmation from Verifiable Credential Service, my API calls function app, and this function app through the signaler service communicates with the web app, and this label and confirmation is displayed in nearly real time in the web application. So it's also cool that we can have information about different steps that are happening in the Authenticator app, in the mobile app that user owns. Okay, perfect. So now let's see what we have in the issue new verifiable credential async method that I implemented. So in this case, here, let's go to the implementation. It's very important. We have this method called issue new verifiable credential async. So first of all, as you notice in the web application, there is this pin displayed. And this pin has to be provided in the Authenticator app. This is for the security enhancements. So once user, before the user, before the user can get the verifiable credential, in this case, user has to scan the QR code, provide the PIN, and then the verifiable credential can be issued. So this is the place where this PIN you saw in the web application is generated. And below, this is the place where we communicate through the REST API with the Azure AD Verifiable Credentials service. So as you can see here, I have to provide multiple parameters I show you in the Azure portal. So the authority, information about the callback URL, information about the state. So everything has to be provided here. And of course, it's quite complicated. So this is why I encourage you to go through the official documentation for verifiable credentials, because there you will find the details about those parameters. And I did the same. I just go through the verifiable credentials documentation, and it was quite clear how should I use those different parameters. And this great blog post, also I reference in the video description, will also show you how to do it. But in general, I have to create this issuance request. And what is really important to mention, please note that if I scroll down in the issuance request, I have this information about the patient. So there is the patient ID and patient name. So this is the place where I can inject those claims in the verifiable credential. So again, as I mentioned, you don't need Azure AD, Azure AD B2C as identity providers to be able to generate verifiable credentials. You can get those claims somewhere from some other places, and you can inject them here in the claims. And of course, before we can communicate with Azure AD Verifiable Credentials API, we have to obtain the access token. This is exactly, when it comes to parameters, this is exactly like previously described in the official documentation. So once we got this access token, using a get access token async method, which is here, as you can see, we use client credentials flow in this case. And once we obtain this access token, we can call verifiable credentials service. And this is the place where we do it. And when we do it also, I mentioned that Azure AD Verifiable Credentials service can call this issuance callback, this endpoint I showed you in the controller, yeah? So to get information, for instance, that user successfully scanned the QR code, or that the verifiable credentials was successfully issued. So where is the magic? How verifiable credentials service knows where this confirmation should be sent? There is no magic. Like in this issuance request, please note that here in the issuance request callback, I have to provide this issuance callback URL. So I just indicate, please inform me about the status change when it comes to verifiable credential under this URL. So this is my endpoint under which I'm waiting for updates from verifiable credential service. So there is the magic. And also there is this API key. You can use it, you don't have to use it. If you want to, secure this communication between Azure AD Verifiable Credential Service and your endpoint of the API, you can add this API header here and you can validate it. So you can be sure that no one else can call this specific endpoint, only Verifiable Credential Service. Okay, perfect. So once the verifiable credential is successfully issued, this notification is sent. So my API here, let's see what's happening here. Once the verifiable credential is issued, let me show you. We have this callback here, as I mentioned. Yeah, so I will have information about state updates. I have another class implemented. So as you can see here, this is the place where I'm sending those updates to the function app responsible for sending the real-time updates through the signaler service to my web application. The signaler service and function app is not the topic of today's meeting, but I want you to know that in the solution you will find this live notifications function app, and this function app is responsible for sending live updates through the signaler service to the web application. And this function is responsible for sending those updates about the information that user successfully scanned the QR code and that verifiable credential was successfully issued. And in the Cloud Pharmacy Store web API, this function app is integrated to send live notifications about the fact that user confirmed his or her identity using verifiable credentials. So the discount can be obtained in the Cloud Pharmacy Store. So there is no, again, magic here. We're using live notifications function app to send those messages. Perfect. So right now, let's back to the Cloud Pharmacy Store web application. Here is the Cloud Pharmacy Store web application and the list of medicaments. So I can click Buy, and here is the QR code generated. I can, of course, scan this QR code with the Authenticator app. And once it's scanned and I confirm that I can use my verifiable credential to prove that I'm the patient, I will obtain the discount. And again, when it comes to the mechanism underneath, it's quite the same as described for the issuance. So in this case, I have to scan the QR code. Once the QR code is scanned, there is a permission request in the Authenticator mobile app. And once I allow to present my verifiable credential, I can obtain the discount. So now let's jump to the Visual Studio to discuss what's happening there. As I mentioned before, there is this second controller called Verification Controller. And inside this controller, we have two methods, two endpoints. Generate presentation request async and presentation callback. So the first method is responsible for generating this presentation request and to present the QR code in the web application. And the second method, so the second endpoint, is used by Azure AD Verifiable Credential Service to publish information that user successfully opened this verification request, presentation request in the Authenticator app, or that the verifiable credential was successfully verified and user can obtain the discount for specific medicament. So it's exactly the same like with the issuance process. We need this presentation callback to just get information from the Azure AD Verifiable Credential Service that something has changed, and for instance that the user has successfully presented the verifiable credential and can proceed with the discount. So now let's see what's happening in the existing verifiable credential async method. If we scroll down in this service, you can see here that exactly like in the previous case, we have to generate some request that will be sent to the verifiable credential service. So in this case, it's verification request. In this case, we want to also include the QR code so the patient can scan it. And also we have this callback property here. So again, no magic. I'm just indicating that I want to call this presentation callback endpoint in my API, and I want to send this information through the function app, notification function app, to my web application using sign-alert service. So in this case, here again, those different properties like presentation, registration, authority, all those properties are explained in the official Azure AD Verifiable Credentials documentation. So I encourage you to go through them because they are well explained. But in general, the concept is the same. So I have to first obtain the access token to call Verifiable Credentials service. And once I have this access token, I can post this presentation request to the Verifiable Credentials service. And then in the response, I will get this QR code. I can send this payload to the web application. The QR code is displayed and patient can scan this QR code. Patient is asked whether the patient would like to present the verifiable credential and use it. And once it's approved by the patient, the discount is added and the final price of the medicament is decreased with the amount of the discount. And again, when it comes to notifications, the process is exactly the same. So once I scan the code and I approve verifiable credential in the Authenticator app, presentation callback endpoint is called by Azure AD Verifiable Credentials API and service. And once it's called, here I have this another implementation which is responsible for calling my live notifications function app, and this function app through the sign-alert service will send this message nearly real time to the Cloud Pharmacy store web application. And that's basically it. I know that this is like a really short overview what's happening here underneath. I plan to prepare more videos around this topic, verifiable credentials topic. But in this video, I just wanted to present how verifiable credentials are used, what is the source code structured, and what is the flow when it comes to generating verifiable credentials and verifying them. So I encourage you to visit GitHub repository under this link, and link is also provided in the video description to learn more about code implementation. And I really encourage you to check the links I provided in the video description. Thank you so much for watching this video. I hope you found it interesting and helpful. If you want to learn more, I encourage you to check the links provided in the video description. And please also subscribe, because this will be the sign for me to produce more videos. See you in the next video.